You well.
Thanks, buddy. Hey, everyone. Cool. So there's a great opening piece in this segment that said, "We are scientists." So this talk will put that to the test for you guys to see how scientific we are. Because really, this is a talk about causality. And this is a talk about how we use experiments to figure that thing out, and how we also think about changing how we build our products because of it. So I'm really going to share a little bit of a motivation for experimentation, then touch on some things Skyscanner have learned over the while, and share some practical tooling at the end that you guys can use to help. So on the above probably looks familiar. If anyone's building internet-based products, you want to make a change to a new feature or improve something or ship something, you release it, and metrics should improve, mostly, or at least they should change. They may be worse. But that's the ideal, right? That's correlation. That's how we, most of the time, if we're not experimenting, measure things. But in reality, we have this other thing to worry about, this other variable, that is everything else in the world. So if we make a change and metrics improve, how do we know it was our change and not marketing, not seasonality? Maybe a plane crash happened, and if you're a travel business, this changes metrics. So experiments are the way of cutting this line from the red box to the pink one and removing it. And of course, the prominent methodology is A/B testing. This is A/B testing in a slide, just to make sure we're all on the same page. So usually, you would have some population of users. You want to segment those into treatments, control and challenger, potentially. And from there, you will compare the differences, see if the change is significant, see if it's better, see if it's a win, see if it's something to ship. And the key is that actually, in theory, this idea is pretty straightforward. But in reality, it's quite tricky to do this, and that's some of the things we'll touch on here. I've lost the slides down here, by the way, so keep looking back. A case for A/B testing beyond the case for causality, well, there's a few things. First off, it allows us to rely on data rather than intuition. It's not to say intuition's a bad thing, right? You saw a great talk this morning on that. But also, it allows us to remove hippos from the decision-making process. You may have heard of that phrase, making decisions based on the highest-paid person's opinion rather than what's going on in reality. So experiments are a way to get data that we can use to make better decisions for users, for partners. But also, there's the idea that experiments are just for small changes, they're for making little incremental things. But that's not really the case, and we'll show some of that in a moment, that you can test everything, really, from a small change to a new feature to an innovation that you come up with. And also, you can test anywhere that you can randomize users. So at Skyscanner, we run experiments on not just the web, also native app, bots, email campaigns. Anywhere we can take a population of users and randomize them is a good place for running experiments. Some trivial examples, just in case it's still not clear. We may want to test a button, right? Maybe you think search flights is better than search. Could be. Raise your hand if you think the search flights would be better for a search company. Yeah, about 50-50. So the key is we shouldn't really worry about that. We should just use a test, get the data. It also could be a more extreme version, right? Or a bigger change, like a full new recommender engine that we've introduced here on the left. Replacing static content. Still, A/B testing is a way to test that thing, get it live in front of users, figure out how people are responding to it. And this is really more like exploring, I suppose, more exploring the possibilities of what we could do rather than just exploiting the current features. And there's also the idea that we should use experiments to secure changes as well. So let's say we've run this recommender on the homepage, and now it's better. We want to remove the prices to improve performance, to improve the engineering efforts, to reduce the cost. But we do that without a test. It could be worse, who knows? And in this scenario, actually, we removed prices, and the challenger was better. So sometimes you just bump into winners like that. But the key idea is that experiments are not just about incremental improvements. They're about securing things, about exploring new ideas. So hopefully we're all on the same page. It's fair to say at Skyscanner we take experiments pretty seriously. We run a lot of experiments at a time. Per month, we run at least 300 A/B tests, which is pretty big for most internet teams. But relative to that number is, it's not only about the amount we're doing, it's the amount of teams that are running these experiments in the first place. So we actually have more than 30 autonomous teams running A/B tests every week, every day. And they're distributed across all of these locations you can see here, all of which are hiring, by the way, if you're interested in coming to work for Skyscanner. But the key idea really is that running autonomous teams has its own challenges, but especially teams running experiments. And that's what we're going to talk about next. It has led us to what you could call our mantra or our philosophy, which is design like you're right, test like you're wrong. It's a pretty good phrase. This is usually the only thing people tweet, so feel free to do that. And the key idea is that we want to be as creative as possible with ideas. We want to come up with as much cool stuff as we can. We want to build great features, build great recommenders, build bots, build all these nice things. And we want to use intuition. We want to use our creativity to drive that. But as soon as we come to deploy, then we want to switch into the science mode. OK, we are scientists was the opening tag. Then we want to test like we're wrong. We want to say, OK, how can we see if that thing is right? How can we try and disprove it rather than prove it? And you'll see why that's important over the next couple of examples. And the first is that actually it's easier said than done to think critically like this. So this comes back to the internal tool we create in Skyscanner that is called Dr. Jekyll, which of course is a reference to Dr. Jekyll and Mr. Hyde. If the animated GIF doesn't sell that to you, Google the book. But the key inference that we were getting when we joined, when people started running these A/B tests, they made this observation that actually teams, when they launch their first experiments, think that they have a split personality. You launch it one day, it looks better. Check it the next, it looks worse. It's like, check it the next day, it's better. Like, what the hell is going on with things? And that's just how inference works with the methodology we use, and we'll touch more on that. But also, it's really easy to arrive at the wrong conclusion. There's the idea that if I A/B test, like, I'll get trustworthy data. But actually, sometimes A/B testing can lead you even more astray than just using your correlation. Because you're getting the idea that this is a really solid, gold standard way of doing things, but equally it's easy to trip up. So let's look at a few of those things. First is false detection rates. This is not well understood, that if you're using frequentist methodology like most internet teams, you probably are using an alpha level or a significance level of around 5%, which means this framework isn't certain, OK? So even if we run a bunch of experiments, 5% of the time we will still get it wrong. We'll get a false positive, which is fine because we want to go fast. We want to test a lot of things. And if we do 100 things and 5% of them happen to be false positive, then we're still in a good position. But what's less understood is, with a lot of traffic, there's temptation to add more treatments. It's less understood that if you add more, in this case, B, C, D, E, F, that false positive rate jumps above 20%. So how do we think about that? How do we correct for that? These are some of the engineering challenges we're working on. How does the tooling help figure that stuff out? We want to test more things, but we don't want to get more false positives. On the other side, there is the idea that it's quite easy to get a false rejection. It's quite easy to get what is a false negative, and that we test a feature, we think it's going to improve metrics, and it doesn't move metrics at all. Or at least we think it didn't, because there could be two reasons. It could be the feature didn't do that, or it could just be that the feature hasn't been well powered. So I won't go on too much more about the statistics of experiments, but we're sharing some stuff on this, and this is some of the key things to keep in mind. Secondly, the idea of actually how you sample users is less intuitive than you might think. And we can use the analogy of this room, actually. It works quite well. So if I'm giving this talk, I'm presenting to 3,800 developers, I think it was. It's pretty big. But I could assume, OK, the whole audience is going to hear this. I'm assuming the microphone works. I'm assuming everyone that's been queuing all day actually got in the building, et cetera, and they're not still in the gents queue. But the key thing to think about is, if I actually only really reach maybe the first 10 rows, and then I make an inference on the whole population, like things would go wrong, OK, I could get it wrong. And some of the practicalities of this for A/B tests is potentially we deploy a feature, and it really had a bigger population than those that would truly be participants. Maybe it was a thing you had to interact with some other feature first. And also, maybe sampling all of our users was a bad idea. Maybe we should test a feature. If we want to test like we're wrong, maybe we should just test it on one browser, test it quicker, see if it works, and then scale out to the rest. Maybe one market, okay, instead of spending longer testing this feature for everyone, maybe test it in the UK, see if it works, scale it up. And also ramp up. We don't want to just deploy things to everyone. We want to ensure that we can be safe. We want to deploy at small percentages, see if it works, scale it up from there. So this little area as well is an engineering challenge we're currently working through. This one is even more tricky, is that if we want to run 300 experiments at a time, then this happens. Okay, this is one experiment that says get more out of Skyscanner. This is another experiment that says feedback. And then there's another one that says get even more out of Skyscanner. So if you're the unlucky person that got B, B, and B, then you start getting things like this, right? You start getting crazy experiences. So how do we use the capabilities of engineering? How do we build the products that allow us to remove these sort of barriers so we can keep testing more things? Because we don't just want to test many ideas at once as a business and avoid teams not crashing into one another. We also want teams to test more theories at a time. So if I'm working on a homepage, I don't want to make one bet and just test that. I want to make more. I want to run them all. I want to see what's working. And this is the power of experiments at the internet economy, that we have the traffic to do this sort of thing. So we're developing some features around this to automatically bucket users, to think about how we avoid that. It's a little bit of a data science challenge. And another is actually, the idea of peer review is pretty tricky when you look at this sort of scale. That we need some formal template to help teams share with one another. So if everyone comes up with a slightly different hypothesis method, let's say, then I could read what your test was, but then I need to figure out on your Jira ticket what was going on. Like, what did you mean by that? What was your evidence? What metric do you care about? And also, how we share this stuff at large scale is tricky as well, and by no means a problem we've solved. That we're running lots of experiments. How do we get the same capabilities and learnings from one team to another? How do we avoid the duplication? How do we scale science? And you'll see the framework we've presented here, and one of the key points is really it is good for standardization. And there's lots of benefits of that. Of course, engineers will be familiar. And other organizations start to pick this up, start to use it. So if you're running experiments, you'll hopefully find this a good starter. But just to recap on where we start, really, is thinking scientifically isn't natural, even to developers, even to data scientists. In fact, this is natural. If you build it, they will come. This is a real experiment from our internal product. You can think of the problem with that. Build what? What's the metric? Think of that false positive problem. Think of all of these ideas around how long we test it. And it shouldn't surprise us, because the other side is we know loads about human behavior and how people make decisions and how people think about their ideas more valuable than others. Check out this thing called IKEA effect from a guy, Dan O'Reilly, that says if we build a feature, if we build a product, we'll overvalue it more than a comparative product that someone else built. So this is just human nature, and the key idea that where they be tested, it's not just about an engineering task, it's not just about a scale task, it's actually correcting for human nature, to think like scientists, to scale that challenge. And this is the success we've had so far using this tool. It's a simple step. It'll get you started. And the key is that you can check this out on the blog after, and I'll link to that. But you can see here a couple of the things that I've talked about are corrected already. Like, for example, there's just a standard format you can use. So if I read this and I read someone else's test, I know what they're trying to do. I don't need to go and look at visuals even. I can just make sense of it. But come back to that design like you write idea. So we want things based on evidence, probably, if we have it. We want to make a prediction that a change we make, whatever that is, will do something to some metric. We want to avoid harking and hypothesizing after results are known. And then to test like you're wrong, really this is about a power analysis to figure out if I want to disprove that theory, I want to disprove that hypothesis, how many users do I need? How long have I got to actually learn about that thing? Okay, I don't just want to test it forever and see how metrics change, because there's a pitfall there known as early stopping and multiple comparison. We want instead to go, what is the sample I need? How long am I going to learn about this? And then crucially, what is the difference that would have to happen? Which is called the minimum detectable effect. But really, it means this feature has to be at least this size. Maybe it's 1%, 2%. And if you test it and it's less than that, then you don't see anything, okay? You don't accept. You've got a challenge to keep scaling up, try a new iteration. But finally, just to show you what's next for experimentation from our perspective, amongst these sort of more basic introductory things and how to form hypotheses and how to run things, it's actually, when we're running a lot of A/B tests, it's starting to change how we build our products entirely. Historically, you can see on the side here that a standard A/B test setup would just have some code, and that's a variant, and then you test it, and then you see which of those two things are better, and then you probably have to stop the test, take the thing down, deploy it properly, put it in a sprint process, something like that. So there's a few problems with that. One, when we found a success, we don't really want to take it away from users again, especially on popular products like ours, because people tweet about this stuff, right? And they say, hey, that cool feature's gone, what's going on? But also, we want to make sure that it's really designing and building products for iteration. So we know experiments don't work first time all the time. We know that's not a good methodology if we're using evidence. We know it's more like we'll have some hunch, we'll test some things that will change our direction. So we're really going instead towards building highly configurable products for experiments rather than building experiments. The example here kind of shows that maybe this is one feature and we had a bunch of ideas around it. We want to collapse some data, add some ratings, provider list, swap position, preferred option. So traditionally, you would just choose one of those, or your product owner would, test it and try and work it out from there. But where we're going is to say instead, let's make it really capable to test all of these combinations. Don't literally test them all, but just make the product flexible that when we get our first cut of data, we can iterate quickly. And what we're actually doing with it is, it's not about just doing the change in a simpler way. It's actually, we can push it on the fly. We can do it backed by an experiment. We can do it without a code deploy at all, because the product's configured in that sense. And the key is that we want to let anyone do it, right? Anyone in the business can come in and challenge something and test it. This is a big step for us. Of course, machine learning will play a part here maybe in the future, some of the challenges I talked about. It's another key area. But to come back to what I was mostly talking about today, check out this blog. Pin tweet at McFarland is a good way to get the link. Check it out. Hit me some questions now or after. And yeah, that's all. Thanks, guys.
Thank you, Colin.
All right.
Now we have a couple of minutes, so we've got time for a question.
Cool.
I'll pick the most upvoted one here from Peter. I hope I said that right. He asks, how do you make sure that experiments don't influence each other when you run multiple experiments at the same time on one system?
Cool. So that was I touched on with the idea of overlap. So we've actually built a cohort feature in Dr. Jekyll, our experiment platform, that allows you to basically run mutually exclusive experiments. It allows you to cut Skyscanner in 10, essentially. So you can run in one cohort, someone runs in another, and they can't crash at all. It's impossible to crash. But the key idea to do that is that you need to be really efficient with traffic. You need to not just do 50-50. You need to plan this power analysis thing. You need to figure out the metric. And also, there is a natural divide in some of our experiments through some are on different platforms, right? So they don't really crash. Bot experiments, native app emails, and also markets. We've got an international business with a lot of different locales we can test on, and that helps too. And then finally, actually, the interaction problem with this, if you look at some of the research on Microsoft, isn't as bad as you may think, as in experiments don't interact as much as you would expect them to. So if you don't have the tooling, you should still overlap and then work it out later and react to the occasional chance that things go wrong.
All right. Thank you very much, Colin.
Thanks. Cheers.